Hello dear friends, in this video we will learn some basic theorems on probability. Let us start. First of all, to introduce the concept of probability, we will study axiomatic approach to probability. What is axiomatic approach to probability? There are three axioms. Axiom 1. Axiom 1 says for every event A in class C, probability of event A is always greater than 0. It means in the probability event of any probability of any event is always positive. Axiom 2, if we have a sure event or certain event, then probability of that is 1. It means also means that the probability of whole sample space is equal to 1. Axiom 3, if we have a number of mutually exclusive events A1, A2, A3, so on in a class C, then the probability of A1 union A2 union so on is equal to probabilities of their sum. PA1 plus PA2 so on. It simply means if the events are mutually exclusive, then probability of their union is equal to probability of the sums. In particular, if we have two events, then we can write P union A2 is equal to PA1 plus P2. So it is an axiomatic approach to the probability. Without these three axioms, we cannot go further. So these axioms are basics to two theorems in the probability. The first theorem on the probability, for each A belonging to class C, probability of A bar means complement of A, probability of complement A is equal to 1 minus PA, or you simply say we can write probability of A is equal to 1 minus probability of PA bar. Let S is a sample space. How to write? Generally, we know that if we have a set A in a Venn diagram, so this is our set A. This is our set A. Then this outer portion will represent its complement. Outer portion will what will represent its complement. So A and its complement A bar are always disjoint sets, and both belongs to sample space. If we make the union, we will get this whole set S. Okay. Now taking probability on both sides, since these events are mutually exclusive, so by axiom number 2, we can break them like this PA plus PA bar. And we know that PS is equal to 1 using axiom 2. So it is becoming 1 and this is breaking into two parts. So we get this equation. From this equation, we can get the value of PA bar. Or similarly, we can get the value of PA. Now we have a second theorem. The probability of null set or empty set is 0. In probability, everywhere empty set probability is remain 0. How we will prove that? We know that S is a sample space and S intersection phi is always empty and S union intersection phi is S. Because empty set when add to S it remains S and there is nothing common between sample space and empty set. So we will apply here third axiom. When applying both side probability on this statement, it becomes this. These events S and phi are disjoint events. So by axiom 3, this statement will break into PS plus P phi and this part is PS is equal to 1. So equation 1 becomes PS plus P phi is equal to PS. Cancelling both sides PS, we get P phi is equal to 0. It is a very simple theorem. Another, for any two events A and B in a class of C events, if B is a subset of A, where it is given that B is a subset of A, then we have to prove these two parts, one part and two part. Here, A is a bigger set and B is a smaller set. This portion represents complement of the B because it is the outer side of B, and this portion, yeah, this is wrong here. This portion is represent A intersection B bar. Okay, since this portion and this portion both are disjoint sets, B and A intersection B are mutually exclusive events. Mutually exclusive event means they are disjoint set, they have nothing common. Now, union of these sets B and A intersection B, union of these two sets will become A. Then applying both side probability. Okay, since these and these are mutually exclusive events, so that we can break them. PB plus this part, this is PA, by axiom number 3. So by reshuffling the statement, we get the value of this thing. And we also write A intersection B bar as A minus B. So we have proved here probability of A minus B is equal to PA minus PB. Last one, second part, we know that probability of any event in a sample space is always greater than equal to 0. So probability of PA minus B is always greater than equal to 0. Now put value of PA minus B from this equation. That is PA minus PB greater than 0. From here we get PB is less than PA. Since if any set is a subset of other set, then this result will hold. Okay, moving to next theorem. Probability of any event A is always lie between 1. This is a very basic result. How will we prove it? As we have used theorem 3 here, if B is the subset of A, then probability of B less than A. It may simply means that if any set is a subset of other set, then its probability is always less than other set. So since A is a subset of sample space, a sample space is a bigger set, A is a subset. So probability of PA is always less than equal to PS using this one. Since we know that probability of sample space is 1, so PA is less than equal to 1 because we have used here value equal to 1. And we also know that probability of any event PA is always greater than equal to 0. So combining these two statements, we have proved this one. The last one is for any two events A and B, we can prove that this statement P A bar intersection B is equal to PB minus PA intersection B. How? Look at this as sample space. Okay, this is set A and this is set P. Here this is A intersection B and this part represents A minus B and this part represents B minus A. Now look at this and this 1 and 2. These two parts are disjoint sets and they have nothing is common. So their intersection is 5. If we take union of 1 and 2 parts, it is equal to B, union of 1 and 2. Applying probability on both sides, we get this statement. Since this and this part are disjoint, then whenever two events are disjoint, then the union sign will convert into plus sign. So we can write here, from reshuffling this part to here, we get probability of A intersection bar is equal to this. Similarly, you can prove second part. Whenever you have to prove second part, then you have to take intersection of this and this part. Okay. Please like and subscribe my channel for watching for more videos. Thank you very much. Signing off, Dr. Gaurav Verma.